Hello everyone, welcome to Engineering Archive. Let us look at our last learning problem, number 6. So this question says, determine the resultant force at A. So the question gives us two forces, one in the AC direction and the other in the AB direction. And in order to solve this question, we will first have to express both these forces in their Cartesian forms. So let's get started with AC first. So in order to express the force at AC, in Cartesian form first, we will have to find the length vector from A to C first. In the x direction, this vector travels 6 meters, so we will have negative 6i, since it's towards the negative x direction. In the y direction, it goes 3 meters, so we will have plus 3j, while in the z direction, it goes 2 meters downwards, so we will have negative 2k. Now that we have our length vector, we can find its magnitude. And our magnitude is going to be plus 3 whole squared plus negative 2 whole squared. It's going to be 7. Now that we have our magnitude, we can solve for the unit vector AC, and that is going to be negative 6i plus 3j minus 2k divided by 7. And now that we have our unit vector, we can solve for the force from A to C by simply multiplying the magnitude of the force AC by the unit vector. Well, the magnitude of the force from A to C is 490 pounds as specified in the diagram. So we will multiply 490 by negative 6i plus 3j minus 2k over 7. We can simplify this, and we end up with negative 420i plus 210j minus 140k. Oops, sorry about that. Minus 140k. Okay, so this is going to be our force vector from A to C. Let's move on to the force vector from A to B. So first we need to find the length vector from A to B. So this vector travels negative 2 meters in the x direction, while it travels plus 4 meters in the y direction and 4 meters in the negative z direction. Now we can find the magnitude of this length vector, and we get squared, we get 6. So our unit vector turns out to be negative 2i plus 4j minus 4k divided by 6. Now that we have our unit vector, we can solve for the force vector from A to B by multiplying the unit vector from A to B with the magnitude of the force, which is 600 pounds. So 600 times the unit vector. I'm just going to write this symbol instead of the actual value because I'm short on space. And we end up with negative 200i plus 400j minus 400k. So this is our force vector from A to B. And I'm going to put 2 stars behind our force vectors. Okay, so now that we have our force vectors, they want us to find the resultant force. So notice that they don't ask for the magnitude of the resultant force. All they are asking for is the resultant force. So we can simply find the resultant force in its Cartesian form, and we don't need to find the magnitude. So all we need to do to find the resultant is just add the subsequent I, j, and k values for the two forces. And so the resultant force that we end up with is negative 420 minus 200I plus 210 plus 400J plus negative 140 negative 400K. And so we have negative 620I, oops, negative 620I plus 610J minus 542K. And this is our resultant vector force at A. Alright, thank you very much. See you in the next video.